I want to explain the title a little bit of our presentation, Constant Volume to VAV. What does this really mean? The reason that I entitled it this way, last year, a couple of times last year, I gave portions of this presentation to hospital groups in the state of Florida and talked about this constant volume to VAV conversion. A number of people raised their hand and said, yeah, we're already doing that. And I was a bit confused because I already knew at that point that to do a true conversion, as I'm going to be describing today, you are required to stand before AHCA and gain their approval. And you just don't do that by asking. You have to go through quite a process, and we're going to kind of touch on it a bit today. But this all stems from the ASHRAE 170 2013 7.1 standard, which says that in critical spaces, air changes per hour can be reduced during the unoccupied times of day in critical spaces. It also says that it allows VAV systems as long as the pressure relationship and minimum air changes per hour are maintained in non-critical spaces during all times of day or any time of day. Well, this is true. This was true in every state in the United States with the exception of Florida. Florida did not allow VAV control in any spaces in the hospital. And what many of our hospital clients were under the assumption was that changing the air changes per hour in critical spaces qualified as a VAV conversion. That's really not the true definition, as we're going to try to lay out today of what that is. And certainly there's a tremendous amount of energy that can be saved if this can be done, and you'll see that here in a moment. So in March of 2012, or prior to that, AHCA here in Florida required that constant air volume was the only design that they would accept. Not any spaces anywhere were designed with VAV. After March 15th of 2012, the FGI guidelines were adopted with the building code here in Florida, and AHCA then began to approve variable volume control in certain zones within the hospital in the true sense of VAV control. There are actually 17 zones in a hospital that are considered non-sensitive zones, and the key is this pressure relationship to adjacent areas. And anywhere where an area is defined as not required, that zone by the book is acceptable for VAV control. So that goes beyond admin areas, it goes beyond hallways. It's even applicable in certain patient rooms if those patient rooms are not an infectious disease zone. So as you can imagine, if you're running constant volume throughout the entire hospital, and there's now 17 zones that you can convert, there's a tremendous opportunity to reduce energy in that facility. So what does it require with AHCA? When we did our first project like this, we were hopeful that the only thing required would be a desktop review, which is essentially a letter, short explanation as to what we wanted to do, and they would stamp it approved and we'd be on our way. We were hopeful for that, but I think deep down we knew that that probably wasn't going to be the case. And AHCA does in fact require a stand-up review to convert, in the sense that I'll be discussing today, constant volume boxes to variable volume control. I've actually got a project underway also here in Florida where we're beginning the implementation of this process, and our controls partner notified us just last week that some of the boxes had already been converted the way that we wanted to convert them. So in reality and theoretically, the hospital is in violation of what AHCA requires, that those zones were not approved, to our knowledge, for that conversion. And we actually have already gone through that process with that other hospital that I'm referencing. So it does require a stand-up review, which means that construction drawings have to be developed. And then they have to go before AHCA in a face-to-face setting and have those documents approved. Our first engagement on this, we went to, actually came to Orlando to the AHCA office here, and presented our plans, and one by one the boxes were discussed, the spaces were discussed, and they approved most of the zones that we identified that existed in those 17 non-sensitive areas, but there were some zones that they said no, and it was just their personal interpretation of how that zone might be used one day. So if you've ever stood before AHCA, there can be a little bit of positioning there, sometimes for valid reasons, sometimes not. So what's the significance of all this? Obviously, if we run fans full speed, that costs a lot more than to vary the speed on that fan. This is the fan law, the pump laws. And I've made a couple assumptions here in my example, but honestly, they're pretty close to the real-life example that we'll be showing to you here in a moment. So if the average new variable CFM is 1/2 the constant old CFM, a 40-horse motor can be reduced to 5 horsepower for certain portions of that day. And if you apply the math, assuming certain values for kilowatt hour cost and so on, that's about a $17,000 savings per air handler, just to vary the speed. Now, you can't vary the speed if you're living in a constant volume world, so you can see where this begins to make a significant impact. Here's a study that was done by these gentlemen back in 2011, estimating that 23% of all energy in the world is consumed by fans. So obviously fans, as it should be, if you're in the energy conservation business and your services are trying to help your clients reduce their energy footprint, fans is a big place to start to look. So the client, we have a client that called us about 4 years ago and said, I've got a big problem. It's this hospital. It's Baycare Health System, St. Joe's North Hospital in Lutz, Florida. It's about 400,000 square feet. It was built, let me use my slide. It was designed prior to this 2012 mark in the sand, so to speak. So it was designed constant volume. It was built and constructed and occupied after 2012. And quite honestly, a lot of the hospital market, I'm not trying to help my competition here, but a lot of the hospital market in Florida is not really aware of this opportunity. And we're certainly trying to take that message to them and help them reduce their energy footprint. So VAV not permitted, now it is permitted. What do? We go through the AHCA process and we start attacking that. But they called us, and their real reason for calling us was their energy cost per square foot, in their opinion and in their mind, was out of sight. We'll show you the details of that here in a moment. But they had high energy costs, high energy use, and they had a lot of comfort issues. This was essentially a brand new hospital. It came online about, I'm guessing here, but around 2011, 2012. So it hasn't been in operation very long. So we began to offer some solutions. Obviously, this is a commissioning conference. We're a commissioning firm, and we began to talk about some existing building commissioning processes. There's a lot to choose from. How many firms in here offer any or most or all of these services? How many of you are fans of energy audits? I may stick my foot in my mouth here. A couple people are fans of energy audits. We're not. We do them. Most of the energy audits that we've ever done, a few exceptions, but most of them have not really produced any executable actions for various reasons. So we tend to encourage our clients to use some sort of existing building commissioning process. I'm not going to dwell a lot on our particular process. It is a bit unique. My purpose is not to talk about that a lot today, but we actually are a proponent of this continuous commissioning process out of the Texas A&M University Energy Systems Lab. It's broken into a couple of phases: an opportunity assessment, where we try to get a benchmarking conversation started. We then move to a detailed assessment or the on-site investigation. This is where we begin to talk about the AHCA process and the construction drawings that are going to be needed. We get that underway, and then we go through an implementation phase where we actually implement the measures we've recommended that were identified in the assessment phase. It's when AHCA comes in and makes their final inspection and hopefully gives that stamp of approval. And then there's that persistence phase. Each one of these phases was talked about in the GAP session yesterday. regardless of the particular approach or what you call your existing building commissioning approach, they all have some component that looks much like this. What you actually do in each one of those steps might differ depending upon the actual approach that you're using. This particular approach focuses entirely on making the existing equipment run as efficiently as possible without any equipment modifications or any equipment replacements. That is the entire focus and target of this continuous commissioning approach. So the hospital in Lutz, Florida followed this approach almost to the T. We conducted and completed the assessment phase in 2013. We have just finished the implementation phase early this year, and just a week or two ago, they have incorporated an automatic fault detection ongoing or persistence phase so that they hopefully do not lose many of the savings that have been acquired over the last several years. So the investigation, let's talk about some things that we actually found. Their Energy Star score was 4, not too good, brand new hospital. Their Energy Use Index was 314 as compared to Energy Star Portfolio Manager, which said it ought to be in the neighborhood of 196. And they were spending about $4 per square foot. We identified a number of measures in addition to the conversion of the variable air volume box or the constant volume boxes. That was obviously the elephant in the room and the largest contributor to the savings. This is one reason we just didn't want to isolate on just that one measure, because we knew in this hospital there were likely to be other things that would be applicable to saving energy and improving the environment in that hospital. Now, I won't read a lot of these to you, but common things I'm sure you've seen in your own work as well. One key thing here, as I mentioned earlier, there was no capital improvement or no capital investment, no new equipment. I was talking to someone who approached me just prior to this, and his firm is embarking upon something similar to this, but it sounds like there might be a capital improvement necessary. Hospitals that were designed, I don't know what the magic number is here, but let's say sometime after 2000, probably have a full DDC system controlling every one of those terminal boxes. Those terminal boxes may be actually variable volume boxes operating in a constant volume mode. So that is a very key thing in making this endeavor pay back and have a return on investment that the C-suites will accept. Because really the only fees are involved are the fee for us to push this process, to work with controls contractors to provide the new programming per our direction and some test and balance work. There is a little bit of mechanical modification that is sometimes required. We're not sure that it will be required all the time, but it is not an expensive endeavor. But it has to do again with that pressure relationship back in the return side of the air handlers. So no capital improvement, no capital investment. So this is the scenario during that assessment. If we can focus just on this column, this is what these were the metrics that we calculated prior to the AHCA review. We calculate, I think the number that everyone really wants to focus on is this $395,000 in cost savings. We ran a proper energy model on this facility, modeling all the measures that I previously showed you, and as you would expect, this VAV issue was one of the big items. And we found almost $400,000 in cost savings. So we go to Orlando and we stand before AHCA, and they do their picking and choosing on which zones they will actually allow us to convert. And they slashed, I don't know, 30 or 40 zones from our scope, which meant we had to go back and adjust the model. And we came up with a revised number of around $335,000 of annual savings. So we lost almost $60,000, a little over $60,000 because of, is there anybody from AHCA in here? because of some opinions that existed in the room that day. And some of these opinions were coming from people that were not mechanically inclined, architects, etc. So here's a little review of what we found in that assessment period. We established a baseline. We identified those measures that I pointed out, and we came up with a projected ROI. We identified 136 O&M items. We certainly documented the total energy spend, the energy use intensity, the Energy Star score again, and these are the measures that we identified 12 measures. It equated to about a 19.5% energy savings, cost savings, as I've stated, of $335,000, and a very attractive, as you can see, a very attractive payback and return on investment. So this was presented to the client. They actually took some time to make a decision, if you can believe it. It was more due to the reorganization and the people shuffling that was happening within the organization. But they finally got around to approving it, and we moved on to the implementation phase, where we took that assessment, that plan, and we began to execute it. These are some of the bullet points of some of the things that we actually did. I made this presentation to a client here in Florida here recently, and their whole mantra was, we don't care about energy, we just want to make sure this place is comfortable. So we had to take the emphasis off energy and put our focus back on air quality and patient comfort, which is always part of our plan, and I'm sure part of your plan too when you're retro-commissioning an existing facility. So I don't know if you can read some of those in the back, but we saw some condensation problems. There were some air infiltration happening on the back loading dock, certainly with a lot of simultaneous heating and cooling. As you can imagine, with all this constant volume of cooling coming into the building, a lot of reheat happening to counteract that. And actually at the tail end of the project, some building envelope issues they asked us to investigate as sort of a side project. So a lot of good things came from this, and certainly a lot of savings were produced. These are some of the energy reduction items. We'll highlight a few of these here in a moment in a graphic format, but things, again, that I'm sure you've seen 100 times. You propose the very same kinds of recommendations in your own work. So here's a few before and after screenshots. This is the air handler optimization. This is before. I know you can't see that in the back, but this is air handler 1-6 in November of 2013. That's the supply fan CFM. That is the supply fan output off the VFD, and that's the static. And this is the after picture. And up here in the table are the before and after numbers that you can't see down here. We went from 13,000 CFM to 6,800 CFM. We went from 90% to 76% on the VFD output, and we reduced the static from a 1.4 to just under an inch. And we improved comfort throughout the hospital. This was one air handler out of 25 air handlers. There were 14, can't make 14 with my fingers, there were 14 air handlers that were candidates for the conversion in all of their respective VAV boxes. So if you go back to that fan loss slide that I showed, $17,000 per fan times 14 fans, it's remarkable how close we're coming to that number in the after picture. So we didn't just look at air handlers, we also looked at chillers, what was going on in the central utility plant. Again, another before shot, and this talks about mostly the bypass and the flow. We didn't do anything with the temperature, left it pretty much the same, but you can see before we were at 36% bypass. We went to 25%, and on the primary side, we went from 2,000 gallons a minute to 17. The same fan law applies to the pump law. So you can see, again, the savings can be pretty tremendous if we can get proper control of that plant. And there's a quick screenshot of tonnage of the chiller before and after. On this particular day, we went from 652 tons of output to 383 tons. So again, a significant drop in the work that the plant had to do. So what are the results? My primary job is to seek out new clients that might benefit from this, and I speak a lot to CFOs and CEOs and COOs once I get the facility director on board, and not one of them has ever asked me, how many KBTUs are you going to save me? Have your CFOs in your client world ever asked you that? What do they want to know? Money. So we're going to show you the money here in a moment. This is KBTUs per day over a 12-month period beginning in 2012. That's this piece up here. And in 2016, we were here. This is just year over year. Now you can see in 2015, we kind of bottomed out and we've crossed that line there. I'm going to talk about that here in a moment. But any way you look at this picture, it's a good picture. And if you're a CFO and you just decided to spend $500,000 on this, you're feeling pretty good right now.
What was the increase in 2016
I'm going to share that in a moment. This is the regression equations that we wrote and made our measurements by. The solid line was the actual baseline that we established for electricity and for gas. And the plus marks, again, you can't see that in the back, but you can see the plus marks are beginning to establish a new equation. Anything below that red line represents savings. So it seems obvious to me after the fact, but going into this, I would not have anticipated that heat or gas would have been the primary place that we got those savings. But the gas savings far exceeded the electricity savings here. Simply because, as you can probably imagine and calculate, as I've stated, I think earlier, we're putting all this constant volume cooling into the building, and you're pounding it with reheat unnecessarily, if you can go to VAV. When we were, I tell this story in every presentation I ever give, and it never gets old or less exciting to tell it, but we were in this facility, I think it was about a year and a half, 2 years ago. Actually sometime last year, getting the final AHCA approval. And we're in a conference room with all the stakeholders, and the facility director or one of the facility guys had to step out and take a phone call. And he came back in, he said, you'll never guess who that was on the phone. That was TECO, the utility provider at the gas company. And they want to know what we're doing over here, because the gas usage had just dropped off the table. It was a tremendous, tremendous impact in what people felt about what we did, and certainly the C-suite was ecstatic. Some of the corporate guys got involved. They were ecstatic, so everyone was happy. Here's a little bit about what the EUI did, and as you can see, it had a peak. Well, it bottomed out and began to rise again, but still a tremendous improvement over about a 16-month period. Here's the Energy Star score. We're currently at 19. We topped out at around 23. You can see we got a gap down here, and this is the time from August 13 to May of 15 that they took making a decision to proceed on, mostly due to the exit of the previous decision makers and the re-entry of new decision makers due to some reorganization that happened in the facility. But I mean, we could have gotten these savings almost 2 years earlier had they made the move earlier. And we thought they were going to give us the green light way back in August of 13. And about the time we're about ready to celebrate in our office that we're embarking upon this project, we get the phone call that says time out. We got to kind of take a step back. But they eventually did it. No regrets on anyone's part. Had a significant greenhouse gas footprint reduction. It's what a lot of folks like to see. And what the CFO likes to see is $490,000 that are documented through a proper measurement verification process This particular project, and all of our projects, we use the International Protocol for Measurement and Verification, Option C, which is a whole building analysis. We want to see the utility bills. So every month, starting back in around June of 2015, we began to receive and calculate the savings based on that original baseline that we had established. So in the course of that 15 or so month period, almost $500,000 could be proven to have been saved. So let's look back at the energy model. You know, everyone went out a bit on a gamble on this. We had an energy model that started at around 400,000, 395. It was reduced to 335 due to the AHCA involvement and the AHCA requirements. And if I annualize that $490,000 number, I come up with around $309,000. So all in all, I think we hit it pretty close into what we projected based on a bona fide energy model. And you can see the paybacks there are extremely attractive. So again, the AHCA had to give the stamp of approval and write that letter, and they did so to the director at this hospital. We got the approved stamp. So at the conclusion of the project, we actually suggested that, I don't know if we suggested this or if the client indicated he wanted to do this, but we wanted to know what the occupants, not the patients, but the users of the hospital, the staff, felt about the project. So a couple of questions were put out there. Did they notice any change in comfort? Were they even aware there was a project going on? And what's important to them? Was it the environment? Was it energy? Or was it money? We interviewed admin folks, nurses. I think we might even caught a doctor. What do you think their answer was to this? This is the audience participation part of my presentation. It was actually the environment. Got a winner up here. So I don't want to take anything away from that, but obviously we in this room probably would have been focused on, and they didn't know what the energy savings were at that point. But several of them commented on, yeah, the place feels better, less heating and cooling complaints. The engineering staff of the hospital absolutely said the hot and cold calls had almost become non-existent. Now, there was a question, and I realize I haven't answered it. Why did the energy go back up, or the energy savings go down? The project really ended in earnest about November of 2016. We had a few more reporting phases to go through, and we officially called the project complete in the early part of 2015. So we began to see, really prior to the November timeframe of 16, that the energy was beginning to erode. And we had proposed, and this again is in full synchronization with some of the things discussed in the GAP session yesterday. We had proposed sometime earlier in the year that this project will eventually close down, and we've had a tremendous success. Everybody agrees with that, but statistics and studies show that within 3 to 5 years, all of this will go away if you don't have some level of persistence or sustainability program in place. Here's a proposal. And we proposed an automatic fault detection and diagnostic solution, significantly less expensive than all the money that had been spent thus far, which gives firms that use that technology eyes and ears into that facility and can begin to pinpoint when equipment is beginning to go south, so to speak. And they delayed and delayed and delayed and delayed, and just last week they finally said, okay. So we hope we can turn that curve back around, but some specific things that are going on that we're very much aware of. We have told them, and I'm not trying to throw my client under the bus, but we've pointed this out long before this energy began to go the wrong direction, that their airflow measuring stations needed maintenance. And if you're not measuring that air properly, you are controlling that fan improperly, and hence the increase in energy. That has a lot to do with that, whoever asked that question.